So to wrap this up, I have all the information from before. This is my little calculation for figuring out the number of number of meters per page. Very small number of fraction of a meter. The apparatus length, that's from this point down to this point, and that's going to help us figure out the angle here. So the apparatus length was 17.3 centimeters. The rolling bar itself had a length of 3.8 centimeters, mass of 13 grams. And so putting all that together with our data, I've just kind of summarized everything down here. This should make it a little bit more succinct. I'll give you a nice picture at the end of this video of this data here. We've got F equals Bill applied. This is a side force diagram, coming in from the side of the rolling bar. So there's gravity, it's weight acting on it, the normal force from the bar, and the magnetic force that should be applied to keep this bar in motion, keep this bar at rest, keep it from moving. And I've summarized the rest of the information here. L for F equals Bill will be the length of the bar that's touching from here to here. So the rolling bar contacts the two beams 3.8 centimeters from one another, so at those 2 points. So L would be the length that the charge has to travel to get across that moving bar. Again, summarized it, mass of the bar, and the calculation for height. Now this is going to go into helping you figure out the theta. So sine of theta is h over 0.173. That would be the opposite side divided by the hypotenuse of that triangle. I've redrawn it down here. So if this is the book holding up the apparatus with a length of 17.3 centimeters, each of those different heights is calculated using this little formula here. So please use that. That should be a help. And here's the summary of the data. I put it in order from 1D battery to 2D cell, 3D cells, and 4D cells is what a 6-volt battery is. And there's the data we collected. So that should help you. Your job now is to figure out what should you plot so that we can determine B, the magnetic field. To point you in a direction, this is something like a line, an equation of a line. Now we don't have a y-intercept in this equation, all right, but if you plot something versus something, we should be able to determine the B's. So find some data points, work it out, and something about your slope of your line that you plot. Should do like a line of best fit for 4 different data points. Hopefully those data points are mainly in a line there, but something about your slope should determine your magnetic field. So can you determine that? That's your challenge. Go to it, talk to one another if you need to, find some classmates, and I'm always here if you have some questions. Send them to me. Hope you have fun with this. Bye-bye.